Sample problem 3-2. I'm going to run through this quickly. Again, this is in your textbook so that you can go through this at any time. What is the mass in grams? Okay, so our final answer needs to be in G, grams, of 3.5 moles of the element copper, right? Represented as Cu. And so again, we have to take a systematic approach to this. If you take a systematic approach to this, things are going to fall into place really, really well for you. If you're trying to make up some new system that's different from what I am trying to share with you, not to say anything about your abilities, but it's probably not going to work. Okay, I'm going to use this system because it always works, regardless of how complex the problem is. Okay, that's why I'm using it, and I want you to use it so that you can still function regardless of how complex the problem that I'm giving you is. So please follow this system. First up, let's talk about what we have. Okay, we have givens here. We have givens. 3.50 moles of copper, right? Obviously, we got that from the question. And just in concept, what we're trying to accomplish is take this amount of copper in moles, because that is in fact what the question gave us. We want our answer to be in terms of grams, right? Mass of copper in grams. So there, figure 3-11, okay, which I believe you'd have to go back in the book like a page or a page and a half to find that particular figure, but it's there. For kind of like more of you your visual learners out there, you can see that graphic. We see the mass of an element in grams can be calculated, which is good because that's what we're being asked to do, calculate the mass in grams, by multiplying the amount of the element in moles, which is nifty because that's what we've been given by the problem, by the element's molar mass. And so what I want to do here before we look at numbers at all is this kind of concept progression. So notice on the left, the term that we're starting with is moles of copper. Moles of copper. And we're going to multiply it by a fraction. Okay, it was a fraction, right? Numerator, denominator. Okay, fraction. Remember, we're not allowed to change the value of what we've been given, right? The actual value of what it represents in reality. We can't change that. Even though we can change the unit with which we are communicating that information, the actual value has to stay the same. So the rule is, if you're going to convert units, you have to multiply by a fraction that is equal to 1. Because if you multiply by a fraction that is equal to 1, that means that the actual data, like the content of the information itself hasn't changed, but we can successfully change the unit. Okay, so that's key. And so you see that we're going to multiply by a fraction here. Before we get into the numbers, I also want to point out one more thing. And this is going to be a pattern that you can recognize. And if you recognize it earlier, it'll probably help you. Well, it will help you. Notice that I've been given moles. I started with moles because that's what the question gave me. And notice when I look at this fraction, the denominator has the same unit as what I've been given. That's going to be the common theme. Okay? This is my conversion factor. Right? I'm trying to convert out of some unit and into another. Well, you remember when you divide something by itself, you get to cancel it, it goes away, that unit gets to go away. So you're going to see this pattern a lot. Okay, in that first conversion factor, you want to put the unit that you've been given on the denominator. So you're gonna see that pretty darn regularly. Scroll down a little bit so we can see it. So now we can actually plug in some information and see how this actually works out. Put that down about right there. That'd be easier to see. So the molar mass of copper, again, are you supposed to know what the molar mass of copper is just off the top of your head? Absolutely not. From the periodic table, guys, from the periodic table. Even your textbook says, look at your periodic table, okay? So do it, right? I mean, not right now. Like when we go through the practice problems, do it then, right? But I'm getting this from the periodic table. I haven't memorized this stuff. I mean, seriously, I haven't. The molar mass of copper from the periodic table is rounded to 63.55 grams per mole. And when I say rounded, just means that there are several more digits that would go out here, right? They get pretty darn exact, but we don't need to be that exact for this course. That makes sense? If you were like if you're in a laboratory, you might want to be more precise, more exact, I should say. But we don't need to worry about that. So your textbook actually has stated that it's going to do these calculations with 2 decimal places. Okay, so that's going to be a pretty common thing that you'll see. So again, we started with the moles of copper, okay, and you can see that moles of copper, not only is it what we've been given, it's on the denominator of our conversion factor, and you can see that your textbook has indicated that they cancel out. Now the number, the value, okay, the magnitude, that doesn't cancel out. We're still going to do something with that. But you see the only unit left in this whole darn thing is grams. And so that allows the unit on the answer to be grams. A lot of students have issues figuring out where to put these numbers. For example, students will say, or they'll ask, does the 63.55 go on the top or the bottom? What I say is you are missing the point. Okay, you're missing the point. You haven't considered the thing that I want you to consider. Look at this fact that we've been given from the periodic table. That means that 1 mole of copper is equal to 63.55 grams of copper. That's called a statement of equality because these two things are the same, right? They're equal amounts of stuff, right? Statement of equality. I'm stating that they're equal sign. Now here's the thing. We already know that we've been given moles, and in order to cancel moles, we have to put moles on the denominator. Yeah? So by default, the grams would have to go on the numerator. Well, if you know that, you know where this is, right? Moles is on the denominator. So if mole is on the denominator, the number that goes along with mole is going to be on the denominator. And we see that grams are on the numerator, and so that means the number associated with the grams is going to be on the numerator. Okay, so actually writing out your statement of equality is very, very helpful, and writing down where your units go first is very, very useful, meaning plug in your numbers absolutely last. Absolutely last. So let's check to see if this answer of 222 grams of copper makes sense. Because the amount of copper in moles was given to 3 significant figures, right? Because we still need to consider the appropriate number of significant figures. The answer was rounded to 3 significant figures. The size of the answer is reasonable because it is somewhat more than 3.5 times 60. And think to yourself, why is that reasonable? Why does that make sense? Well, if every 1 mole of copper has a mass of a little bit over 60, and I have 3.5 of those things, that makes sense that I'm going to be essentially doing a 3.5 times 60 type calculation. So that sample problem 3-2.